Yes?
Yeah.
Okay. 54 on the non-calculator part.
There's 54 twice.
That's why I said it was so fun. Let's do it again. Yeah, okay.
I get it.
Thank you, man.
Do these classes do joke of the day?
All my classes do.
Mine doesn't.
I started that. We
Your
started
classes
that.
don't do joke of the day?
No, we don't.
Oh, that's horrible. Okay,
It's not
solve for solve for x and give restrictions. So we gotta get the x by itself. That's all we're doing, getting the x by itself. So what do we do first?
You
Subtract 2.
Minus 2 to both sides. What I'm going to go ahead and do now is switch the sides so that my x is on the left. So we got 1/3 x h equals v minus 2. Now what do you want to do? Yes?
What do you want to multiply 1/3 by its reciprocal? Or
Yeah, multiply both sides by 3.
yes,
Right? Good. So those cancel out, so we're left with xh is equal to 3 times v minus 2. If you want to distribute that in there, that's fine. But to me, that's just an extra step. My whole goal is just to get x by itself, right? Now what?
5, break.
Divide both sides by h. So I get x is equal to 3 times v minus 2 all over h. And then my restrictions. What are we talking
Is
about?
that an I?
It's a semicolon.
Oh.
What are they talking about with any restrictions? Restrictions on what?
Oh, like.
0.
On the variables, right? The variables could be any number, right? But sometimes we can't have a certain variable in a certain place be that certain number.
0.
We got a problem here, don't we?
Yeah.
What happens if h is equal to 0?
The whole thing's 0.
We got a big problem, don't we?
Yeah.
6 days,
Yeah. 6 days. What?
world will explode. Did I go over that?
No.
You missed that day?
What day?
Aww.
He's such a mess.
Okay, so we have to say that h can never be equal to 0. Basically what you're going to do is look anywhere in your work. It doesn't, not just the final answer. So look anywhere in your work. Anywhere where you got a variable in the denominator. You got to make sure that denominator is never equal to 0. Okay?
can there be any other restrictions?
Good question. Yes. If they're talking about solving for real numbers, you can never have a negative number inside a square root, right?
Then it can be I.
Yes. So another restriction might be if you end up with, like, say x is equal to 4 over the square root of m. Your restriction would be a couple things. We can put it in one. M, first off, can't be negative, right? So it has to be greater than 0, right?
Mm-hmm. But it can't be 0.
And it can't be 0 either, because then the whole denominator would be 0. So it would just be m has to be greater than 0. That would be my restriction.
Oh boy.
Okay?
Yes.
So pretty much those two things. Look out for variables in your denominator, and look out for variables in a square root. Okay?
55 must not be as fun because we only have to do it once. So
Okay.
that's kind of
All right, 55.
Hey.
L is equal to 2k times mt plus m squared times pi. And they want us to solve for t. Okay? What do we do first?
Distribute 2K.
We could. But remember what's our ultimate goal?
Get T by itself.
Get T by itself. So if I distribute, I'm actually putting something with the T.
Oh, how we would want that.
Yeah, that's an extra step, right? Because eventually we'd have to get rid of that.
Yeah.
So why don't we just divide by 2K first, just to move that 2K over the other side. So those will cancel out. I'm going to switch the sides so that my T is on the left. So I have mt plus m squared pi is equal to L over 2K.
Getting closer.
Now what?
I don't know.
Divide by M.
I gotta get rid of this, don't I?
We-
Subtract it over.
Sure.
Minus m squared pi to both sides. So I've got mt is equal to L over 2K minus m squared pi.
Dang.
And then divide by,
T.
now we're trying to
I mean,
solve for t, right? So divide by m. So I've got t is equal to L over 2km minus, here I got two m's up top, right?
Ooh.
And one on the bottom. So 1m top and bottom will cancel out, so it'd just be minus m pi.
And we have the
And then-
restrictions.
Some restrictions. Anywhere I had a variable in denominator, here,
K or M.
k cannot be equal to 0,
And neither can M.
and I had an m in the denominator, didn't I?
Yeah.
M cannot equal 0.
What chapter was this in, Mr. Bell? Because I don't think it was there for this one here.
It was towards the beginning, you just solved, this is just basic algebra, moving stuff from one side of the equation to the other. It's early, I think. 56.
It's easy.
Solve for x and identify the restrictions. 2x minus y is equal to 8c. Add y to both sides. 2x is equal to 8c plus y, and then divide everything by 2. So x is equal to 4c plus y over 2. And our restrictions,
None.
no restrictions. Everybody okay with that? Why are there no restrictions?
Because they're orange.
Because I never have a variable in my denominator,
Correct.
okay? And divided by 2. 2 can never be 0. It's 2. Alright, 57. Give the slope of the line parallel. 5x plus 2y is equal to 12. How do I find the slope of the equation? How do I find the slope of this equation?
So we could put in like,
Put it in slope intercept.
Put it in slope-intercept form, right? And then, what do I know about the slopes of parallel lines?
they're the same.
They're the same.
Yeah.
So, let's find this one. Minus 5x, minus 5x. 2y is equal to negative 5x plus 12. And then divide everything by 2. So y is equal to negative 5 halves x plus 6. The slope of this line is negative 5 halves. So the slope we want M is equal to, it has to be the same, right? Emma, can you hit that?